Good morning, everyone. Continuing with LISP, we review atomic values, primitive values. Then we review lists and some of the instructions that are available, words or the ones that replace operators. Now we need to move forward with the next level of instructions. And as we mentioned at the end of the previous lecture, conditions and loops. We need that. We have that in every single language that we have reviewed. So something should be here to give us access to that different paths of execution, loops, conditions. Now, the control structures. The control structures in LISP are not considered functions, even though they look like a function. But just to give you the theoretical background, the control structures, the ones that we're going to review, they are called macros. Just in case you read that term in the book or in some source, they are not considered functions. However, as you're going to notice, they look exactly the same because, well, one of the key ideas is keep a simple syntaxis, so everything should be the same. Anyway, control structures, the first one, conditions, and as you can guess, the name for the macro is going to be if. Examples. I am pretty sure that you can notice the pattern there. I put some colors, but just in case. If you want to create an if condition in LISP, what you are going to do is to open parentheses and close parentheses, as usual. Second, the first word after you open the parentheses, the instruction that you want to execute is going to be if. Moreover, remember, this is not case sensitive. You can use if, or you can use if, or any combination. Open parentheses, closing parentheses, the first part, the instruction. Second, white space. And what is the other thing that we need in an if condition, and is usually after the keyword if? The condition. The condition is going to be inside of parentheses, not because the parentheses are needed as part of the syntaxis of the if, but because that one is a call to a function. For instance, something like this is the condition for an if. Or maybe you want an if that is always true. The second element is the condition. The condition, a value, true, false, t or nil. The condition, any function that returns t or nil as a result. Any predicate, if you remember, that is the particular name for those functions. Function if, first parameter is the condition. Next, what do we need? Usually, if you have an if condition, you have two possibilities, condition true, condition false. If the condition is true, you execute something. If the condition is false, you do something else. Similar idea. Open parentheses, closing parentheses. Whatever I put there is going to be executed only if the condition is true. Optional, I can put another, and that one is going to run only if the condition is false. You can have only one, like an if without an else, or you can have both. This is the syntaxis for an if condition here. Examples. The first one, I am giving you the instruction in Lisp and in a comment, the equivalent in other languages. Useful reference. If in blue, the condition 3 lower or equal than 2, if the condition, and then red and orange. If the condition is true, execute the instruction in red. If the condition is false, the instruction in orange. In this case, 3 is lower or equal than 2, condition false. If the condition false, then execute the addition of 4, 2, 3. The if, like any other instruction in Lisp, return a result. When you execute the if, you are going to get a result. What is going to be the result of the if? The result of the statement that is being executed. So this instruction, the condition is false. I am not going to execute the red one. I am going to execute the orange one. The orange is going to do the addition, 4 plus 2 plus 3. That is a function, return a result. It's going to return the result, this plus, to the if. Just like that. It's a function inside of a function. And this one is going to print. Everything is a function. Everything returns something, even the control structures, even the if. So in this case, if you copy paste that line, you get the 9. And that 9 is telling you that this one executed because this condition was false in this case. That is an if. Second example. Exactly. Following with the question in the chat. This is like condition, question mark operator, action, colon, action. Now, but instead of the question mark, the if at the beginning and the colon, we do not need the colon. We only use white spaces and parentheses. That's it. Second one. In the second one is an if without an else. And let me be clear. Here in Lisp, always, always, always a function returns something. Always. There is no void. So in this example, if we think about that one being an if without an else, the big question is, well, what is going to happen when the condition is false? Just like in this example, the condition is false. I am not going to execute the instruction in red. That is the second one. But I do not have another one. Well, if you do not have another one, that is your result. Nil. I do not have nothing to do. I do not have a result. If you think about the translation of this instruction to another language, what we are doing is something like this. Always, 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 you have an if, you have the condition, and every single statement inside of the if part or inside of the else part is return something, return something, return something, return something. And if you do not have the else, you have a return. A return is nil or null, always. Now here, you have a 9 without parentheses. yeah, what happened if I want to return the 9? I do not need to force an operation like plus 5, 4. If I want to return the 9, if I am sure that it's the 9 that I want to return, I just put the number. Remember, the parameters can be an atomic value or a function, always. So you can have a combination. You can have something like open parentheses, if t 5, 4. That is a condition. That is correct. If is the macro, the function, and the parameters, the 3 parameters that I need, the condition, what to do when the condition is true, what to do when the condition is false. The condition, an atomic value, true. So it's like if parentheses true in Java, always true. It's not really useful, but it's correct in terms of the syntaxes. Okay, it's true. What is going to happen? We're going to return the 5, just like in this example. When we're going to return the 4? Never. It's an if true, return 5, else return 4. The condition is always true. The return false is never going to run. Again, do not make a lot of sense, but syntactically is correct. It's an instruction in Lisp and can be translated to other languages. So, atomic values without parentheses. The parentheses are because another function is being called. Just remember that one. So, another one. We can make things a little bit complex. Like, can I put ifs inside of ifs? And I didn't put here the equivalent in another language, but we can do it. It's like you are telling me here that you have an if condition, that the condition here in blue is 2 equal to, hopefully you remember the equal in Lisp is just 1 equal. We need to review what to do with assignations, but this guy is this one, C, C++, and Java. So if that condition something, that something here is starting here, all of this until there. Did you notice the gray parentheses and inside we have another things? The only thing that I know is in the else part, the last thing is a 9. The 9, this one, is going to be returned if this condition in blue is false. But if that condition is true, what I have as a second parameter is another instruction if in parentheses. That is the same that having here another if with its own condition and its own body. For this new if, the condition is another function greater than, that is equivalent to this. This in blue is the condition of the if that is inside of the other if. And notice that here, when we talk about inside, is really inside with the parentheses. 4 and 6. 4 is what I want to return if this condition is true. And well, this one have an else. Return 9. So 6. 4, 6, 9. 4, 6, 9. An if inside of the if. And obviously you can put an if inside of the else also if you modify this part. Now, the result here is 4. And the result there is 4 because, well, think about it. 2 equal 2, yes, we run this if. We run the if and we check the condition 3 greater than 2. Yes, we run this instruction. We run that instruction, we return the value. And we return the value here to this if. And that if is going to return the value to this if. Remember, one inside of the other. And this one is going to return the value to the interpreter. And that is the reason because you have that for printed there. Every single function returns something, everything, including the if, which help me with the next example. I can have here the addition of 4 plus did you notice my addition have two things, 4 plus something, only 2 parameters for the plus. The second parameter is a function. So as you know, whatever is the result of the second function is going to be added with the 4, and that is going to be the result of the plus. The problem is what is going to be the result of the second function. Now, my second function is an if. Are you telling me that we can do addition of the number 4 plus an if condition? Yeah, kind of the question mark operator. Now, here, similar to the previous one, it's like, well, I am going to do this function first, and the condition is true. Because the condition is true, I am going to execute this one, the red part, not the orange. And running the red part is a multiplication. I am going to do 9 times 2. That is the result that the multiplication is going to return here to the if, is the one that the if is going to return, 18. And then the plus is going to add the 4, 22. And the plus is going to return that as a result. 4 plus the result of the if, 4 plus 18, done, 22. The if also return something. Any question? Now, in all these examples, what I did is to do the example of the if with only one instruction inside. This is basically my equivalent to the question mark operator. The question mark operator, one of the limitations of the question mark operator is that you only can have one instruction in the if, one instruction in the else. You cannot have a group of instructions. You cannot have what you achieve with the curly brackets. These examples are like that. And I am sure that you are thinking like, well, this is okay. One instruction for the true, one instruction for the false. What happens if we want to have several instructions, more than one, inside of the if part or inside of the else part? We need curly brackets. We need to create bodies, remember? In any other language, the body for the method, curly brackets. The body for the for loop, more than one instruction in the for loop, curly bracket. The body for the if or for the else, more than one instruction, curly bracket. The curly bracket helps us to put together instructions to create bodies. In Lisp, we do not have the curly bracket, no curly brackets. We need something to replace the curly brackets. That something is going to be another function, this function. That one, if you ask me about the equivalence, this is the equivalence. You have a function to replace the curly bracket? Yeah, I have a function to replace this possibility of put several sentences together. The name of the function, proc_n, the parameters, the instructions that you want to put together. All the instructions there, and remember, parentheses. It's a list with list inside. For instance, this example here, I want to create an if, and that if have a condition. But then in the body, I want to do something like curly bracket, print something, and print something else, and return something. 3 instructions. I cannot put those 3 instructions without these guys, because if I do that, only the first instruction is inside of the if and the other 2 are outside, right? I need the curly brackets. In Lisp, open parentheses, and this parenthesis is going to close here. Notice that you can use the enters. I mentioned this before. The interpreter is going to allow you to press enter as many times as you need, and it's going to wait until all the parentheses are closed before running the instruction. So in this case, this instruction is going to run here because that parenthesis is the one that closed, the first one that I opened. The instruction is if. The condition, as mentioned before, 3 greater than 2. Then the next parameter, the one that usually is here after the white space, I am using an enter. It is not mandatory. I use the enter to use better my space in the slide, but you can create a big line, no problem. I want 3 instructions inside of curly brackets. My curly brackets, open parenthesis, prog n. That is my curly bracket. And obviously, that one, the open parenthesis, is going to close in some point here. You can imagine that I am opening curly bracket there and closing curly bracket there, not because the parenthesis, because the instruction prog n. And inside of prog n, I have 1 instruction, 2 instructions, another print here, and the addition. In my example, maybe another print here. 3 prints and 1 addition. When the condition is true, it's going to execute this, it's going to execute this, it's going to execute this, and it's going to do the addition. That's it. If the condition is false, as usual, this parenthesis is not going to be executed. That full parenthesis is the instruction for the true, but it's going to do this one, the last parameter before closing the if. That is the equivalent to have here an else and use something like that. As you notice, it is not mandatory to put the curly bracket because it's only 1 line. Usually, just to make this clear, you can put this here. In the same way, you can use a prog n instruction and put inside only 1 parameter. That could be the equivalent to use the curly bracket, having only 1 instruction inside. So prog n, your replacement for bodies, your replacement for the curly bracket. This is going to work with the if, and we're going to use this also with other things, such as creating methods for the body of the method and loops. Good? Any question? The return, very good question. What is going to be the return here? Well, in this case, it's going to return either this line or the prog n. The question is, what is going to return prog n? Because prog n have inside a lot of instructions, right? And all those instructions, this one, this one, this one, and this one, is returning something. All of them are returning something. What is going to return prog n? If I have inside 4 guys, 4 instructions returning things, easy. Prog n is going to return the last one. Just the last one. Create a prog n, create this equivalent to the curly bracket. You can have as many instructions as you want. The last one is the one that prog n is going to return. So in this scenario, all these prints, this is the instruction print here. This is the instruction print here. This is the instruction print here. But then the plus, the 4, it not be printed. I do not have a print instruction here. The result of the plus, the last line, is returned to prog n. Prog n return to the if, and the if return 4 to the virtual machine. Why 4? Because what's the result of prog n? Why 4? Because it's the last line in the prog n. Good? Okay, so far, good. Loops. Because with this, you can create complex if conditions. Now, if we know how to do if conditions, the next step could be, well, how to do loops. The classical version of a loop in any other language could be the for. It's kind of the traditional one. For, one number to start, one condition, how many times, repeat. For Lisp, the main loop, the loop that we usually use, do times. Do times. And as you can expect, it's going to be open parentheses, and the instruction is do times, closing parentheses. So you want to do a loop. In order to have a loop, open, do times, closing. The parameters. What parameters do we need for a loop? Well, for a loop, we're going to need the following. We're going to need one parameter for the configuration of the loop. That one parameter is going to be inside of parentheses. Let me be clear. This is going to be the first time that we're using parentheses, and the first element is not going to be an instruction. Again, the instruction do times have as a first parameter a list of elements in which the first one is not an instruction. So this X here is not an instruction, or the X here is not an instruction. The first set of parentheses inside of a do times, after the do times, you always have a parameter that is parentheses open, parentheses close, this one. And the interpreter knows that that one is one of the few exceptions in which, even though you have parentheses, the first element is not an instruction, it's something else, it's a variable. It's a variable. Why? Because for a loop, you need to have a counter of how many times that loop have worked, just like the variable that you use for the for. Parentheses, do times, parentheses, and the element that you put here is the name of a variable, the name of the variable that is counting how many times the loop have run, your index, your variable I in the for. Okay, what else? Well, inside of that parenthesis also, you put the name of the variable, but the next one is the higher value for the variable, like the value that is going to stop the loop. It's kind of a for in which you have a variable like this, and then you have the variable lower than some kind of value here. That is the value that I am talking about. In Lisp, you will do open parentheses, do times, open parentheses, and then the variable x, and then I don't care about equal 0. I don't care about the lower than 5. That is obvious. 5. Why 5? Is the number that you want to use to stop the loop. Is the number of times that you want the loop to run. That is the information that I need as the source code. Do times parentheses x 5. And you can stop there. You can use close this, and this is the configuration of the loop. The variable that I am going to use, the name of the variable, and the top value, the higher value for that variable. When that variable have that value, the loop stops. Again, it's the first time that this thing is not an instruction. It's whatever name you want to put to your variables. I am using X. You can use cat, dog, computer, phone, whatever. It's the name of your variable. Whatever name you want to use is not a function. Now, optional, you can add one more thing here to make 3 elements inside of the parentheses. Which elements? Well, do time is a function. Do time is going to return something. Something. What? Whatever you put here. Whatever you put there is going to be the return value of the function do times. Did you notice? For some functions, they return whatever is the result of the operation. For others, like proc_n, they return whatever is the last line inside. The do time is special. The do time is going to return what you put in this place, the last value of this list. So if I put here a 5, this for loop is going to return a 5. If I put here hello, this for loop is going to return hello, whatever. Usually you put nothing. So usually you're going to do like this, parentheses, the variable and the top value. I mean, I don't care about the return. And if you do that, the return is going to be null. That nil there is the return value of my loop. The loop is returning nil. It's not because it's an error. Nothing is bad here. It's because, well, you didn't put a return value. So when you didn't provide information, that information is nil. Use what happened with the if else. So moving forward, do times, parentheses with the variable and the stop value, and next. After this, all the other are the instructions that you want to execute. All the instructions. It could be only one. It could be a proc_n, or it could be used several instructions without the proc_n, because the do times include the equivalent of your proc_n, these grouping instructions here. So now, hopefully this example is clear. It's like do times, the variable is x, I'm going to stop in 4. So this loop is going to run 4 times. And the instruction that I am going to execute 4 times is print, and I am printing hello. So hello, print hello, 1, 2, 3, 4 times. And then the nil, that is the return value of the do times, that then is printed on the screen. Done. Now, there is an issue here. usually, if you're going to have a for loop, well, sometimes you're going to need variables. In fact, we are starting working here with variables. And if we start working with variables, as you notice there, I only put the name of the variable. I do not have data types. That is fine. But also, I am thinking like, well, I do not have data types. This variable is an integer used by default. The computer is going to understand that. The computer is going to use that variable as an integer because it's a counter inside of a loop. Good. But what happens if I want to provide a value for the variable? What happens if for any reason I need a variable and I want to put a value inside of that variable in some point? Usually that is connected with the declaration of the variable, the point in which you put the data type, the name, the value. We do not have data types here. So the only thing that I need is the variable and the value. However, my problem is if this is the variable and I want to put a value 10, usually previously what I used to do is like in math, variable equal the value. I already know that I cannot do this. I cannot do this, number one, because this operator is now for comparisons, not for assignations. Moreover, here, these two, the name of the variable and the value should be together, and the operation go here. So something that is equivalent to the equal should be there, then the variable, and then the value, if that is what I want to do. Now, I know that I cannot use this equal. I need something else there. I need a replacement for the equal that I used to use for assignation. The replacement for that is going to be this guy. Set F is your replacement for the equal in an assignation. So as you can imagine, this line here is the declaration of a variable, a new one. The name of the variable is bag, and the initial value is 2. This line here is that equivalence. How do you know that it's an integer? Well, I am storing as an initial value the number 2, so the computer can imagine that that one is going to be integer. And because integers are anything from 1 digit to whatever you want, I do not need to ask you about short, long, signed, or unsigned. It's just integer. Equal, set F. Yeah, this one is kind of a little bit weird, but set F is like the setters in Java, set function, bag, and 2. Name of the variable first, value next, white spaces. Okay, so this program, that line, create a variable. By the way, when you create a variable with setf, that variable is global. Global? Yeah, you create a variable and you can continue using the variable in the rest of your program. Setf, variables, global. What happens if I want a local? There is going to be another instruction for local variables, assignation of local variables, don't worry. So setf, global. This one, bag equal to a global variable, bag with the initial value 2. Okay, next, another instruction. If you run, by the way, setf, what is going to return setf? Setf is going to return this number. The same value that setf stored in the variable is the same number that setf is going to return, which makes sense. It's like the print returning the same thing that is printing. Anyway, next, do times. Do times. If I ask you to translate that line to a for loop, can we do that? Do we understand what is happening here in that for loop? it is clear that I am doing an integer variable bag equal to here. And then I move forward to a for loop here. And the for loop have a variable x as the control variable. And the top value or the maximum value for that one, the number of execution that I want for the loop is 3. The loop is going to run 3 times. And that the instruction inside of the loop is that one, only one instruction. Obviously, the variable should be incremented. One instruction. Yeah, and the instruction is correct. Set back, this set is the equivalent to the equal for assignation. Back is the variable, and it's going to be equal to something. And that something is this thing inside of the parentheses. And that one is, as you mentioned, the multiplication of this. So can we agree that this one is this one and this 2 times is like this for loop? And therefore, something is happening. Something is happening. This multiplication is happening and is being stored the result in this variable. Why this nil is printed there? Any error, any problem with my for loop? No, it's just because the return value should be here. Remember, x, top value, the return value. I didn't put any return value. This one is going to return nil, no return value. You want to return something? That something should be there, the third element in those parentheses. If not, it's nil, no problem. This is a particular case in which my result is not something that I want to return, but something that I am storing in a variable. I want to print my variable. I want to print bag. And I am using print, but if you go to Java, system out println, if you go to C++, cout, etc. So print bag is a global variable. If I print the variable, it's not going to be the 2 because I use the variable inside of the 4. 256. We start 2 times 2 and we store, and then 4 times 4 and we store, so on. For loops and global variables, for loops and assignations. Hopefully clear. Any questions so far? Good. So now we have conditions and now we have loops, and we can start doing programs a little bit more interesting, like those programs that you did in CSI110, right? The best programs that you did there with Java was programs with conditions and loops. Yeah, we're going to have breaks and continues. We're going to talk about it. Now, here, with this, what can we do? Big parentheses, the set, the variable, the value. If you put in one program the name of a variable alone, automatically the system is going to print the value. So just as a notice, here in my previous example, I will do print bag, press enter, and I can have the result. Or you can do only the name of the variable, enter, and automatically, if you provide the name of a variable to the virtual machine, what the virtual machine is going to do is to print the value of that variable. So you can save time with the parentheses and the print. eliminate that and just use the name of the variable, and that is the equivalent to using the variable. And in the command prompt is to print the value. Similar if you are returning something. For instance, you can have an if, you can have a condition, you can use variables, and you can do something like this. If you have only the name of the variable in the console or in any of the instructions, what is going to happen is, in that example here, if the value of the variable x is lower than the value of the variable y, return x. And x, the value of x, is going to be what this print return, and therefore what is printed. So this is the programming Lisp to return the smallest variable, or the variable with the smallest value. If a lower x, y, x space y. Something that you need to remember, we do not have a return instruction here. The return happens automatically. There is not going to be parentheses return or something like that. If you put here a variable, as in the previous examples, we put numbers, automatically what we are asking is for that variable, the value of that variable, or that value directly to be returned. So examples like this are coming. Anyway, obviously, if we want to do something like this, that one is y equal x plus 3. And hopefully that is clear. Set f is the equal, first the name of the variable, and then you can have whatever you want. In the previous examples, a value directly, like in the examples that I showed you with the loop, but you can put there, instead of the value, another function. And all the operators are functions. So you can do addition, multiplication, division, whatever, to store that. But also parentheses. Set f, a variable, that one is going to be the value. Can I use an if as the possible value for the variable? Yeah, the if returns something. So that something is going to be the value for the variable. Moreover, connecting with the previous example, if the if is this if that is checking which is the lower or greater value between two variables, what I am doing is just like the small value in these two variables is going to be stored in C. Obviously, in order to make this program to run, I need to create those variables. So somehow here, I need to use a setf, another one, and I need to create the variable x. Maybe put some initial value if you want. And in another line, so this is looking more like a program. Now my program is 3 lines, 2 lines in order to create variables, global, x and y, and another line to store in another variable, another value that basically is the smallest value from the previous two. In this example, both are 0, so my third variable is going to have also 0, but you can imagine what happens if here I do something else, call functions, do the process of some data or something. We're going to play with that. But this is one program. And now we have variables, global, and this guy, in the same way that the loop can be used to return something, can be used in an assignation. Good? Local variables. It's like, well, we have ifs, we have fors, we have global. What about the locals? The locals. Let's review this. The local variables are those variables that are created inside of curly brackets and only exist inside of those curly brackets. Think about it. A local variable is inside of the curly brackets of a method and only exists when the program is running between those boundaries. Parameters are a special case. Parameters are considered local variables. Parameters exist in the body of the method, right? But also, if you think about an if in Java, even though the if is inside of a method, if you have an if or a for or whatever, and you create a variable here, can you agree with me that this variable is going to exist only inside of the if? Have you tried to have in Java a program in which you have a method? Inside of the method, you have a variable. Inside of that, you have a condition. Doesn't matter the condition. And is this possible? Can we have moreover a global one? The global one and the local one? Yes, of course. What about another local one? Not in Java. C, C++. The scope. Some languages is like scope. This can be possible because this one exists between these boundaries. If you are inside of the if, this guy is the one local. If you are not inside of this, but you are inside of the method, this is the guy that is local. And if you are not in this method, if you are in another part of the program, this guy is the one that you can use. The scope of the variable. The variable lives inside of a particular zone of your program. This is the way that LISP works. This is the concept that LISP have for local variables. Local variables are not exactly only the variables inside of a method. A variable can be local if that variable is inside of the body of whatever. Inside of the body of a loop is a local variable to the loop. Inside of the body of an if is a local variable to the if. Inside of the body of the else is a local variable in the body of the else. That is going to be the concept here. So local variables, they are more than just the variables inside of a method. They are the variables inside of curly brackets, inside of a body. When you want to create a body, you use prog-n. We already talked about it. If you want to create a body and inside of that body, you want to create local variables for that body, your instruction is let. Let is a similar idea that prog. Let is going to be like your curly brackets. It's going to allow you to put instructions together. But you can create variables here And those variables can be used for any of the instructions, but only inside of these brackets, only for any of the instructions inside of this let function. For instance, setf x4. What is happening there? I am creating a variable x, and I am storing the value 4. That x local or global? Setf global, right? It's a global variable. What is the meaning of global? Any instruction in my program is going to be able to use that x. Okay, x global. Then, open parentheses, let. This is my example, like having this int x equal 4 global, and suddenly I am opening curly brackets, and this can be whatever, again, a method, an if, a for, whatever, opening curly brackets, let. And for the let, what I am going to have is the following: open parentheses, closing parentheses. The first parameter for let is going to be a list. A list of what? Other list. Other list with what? Only 2 elements. 2 elements. Yeah. The name of the variable and the value that you want for that variable. Let parentheses, parentheses, x3. I want a variable, x, local, with the value 3. And as you're going to notice, what I am going to do here is to play with x, and that x from this point to this point is going to be the x local. Because as you remember, local variables have priority versus global variables. I use my local if that local have the same name that a global. Can you have more than that? Can you have like int y equal 5, int a equal 0? Yeah. Open parentheses, let, open parentheses, and you are telling me that you want x with the value 3, and you are telling me that you want the y with the value 5, and you are telling me that you want the a with the value 0. 3 variables, good. Done with the variables, yes. Close the parentheses. These are my local variables all together. 3 local variables. The only thing that I need, parentheses, name, and value. In my example here, I only have 1, so looks like parentheses, 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 and another parenthesis. Well, it's because inside of the first 2, I have all the variables that I want. In that case, 1, here, 3. Okay, what else? Oh, this is one parameter, the first parameter for let, all the other parameters, and I can have as many as I want. Instructions such as print, set, print, plus, and those instructions are going to use all these variables as locals. So if I print x here, hopefully it's clear why I am printing 3, not 4. I have an x here with 4, and I have another x here with 3. I print x, I print the local, not the global, 3. Moving forward, I am going to do a setf. Wait, you told me that setf is to create global variables, but now you are using the setf inside of a let. Well, I told you that the setf is the equivalent to the equal. If you put a variable equal to some value, that is creating the global variable, but the setf is the equal. So the let is opening a block. Inside of the block, here, you create this x equal 3. This one is the local, But what happens if you want to change the value for that variable? What happens if you want to do x equal 10 inside of your program? The equal is the setf. Well, it's a setf, and you are using the x. Is going to be the x local or global? The local. The local have priority. This setf is not creating a new variable because the x already exists. That setf is the equal, the assignation. You are using the setf as an assignation, and also if the variable do not exist, that setf is creating the variable. Yeah, setf is assignation. If you do a setf outside of any other instruction directly in the command line, and that variable in particular, that name do not exist already, it's going to create the variable like the x before. If the variable already exists, the only thing that is going to happen is I am going to change the value. The same instruction, setf equal to create a new variable or to change a value. This one is making x equal 9. As I mentioned before, the x local because I am inside of let. And then I am going to print the x. I am going to print the 9. And then I am going to do x plus x, 9 plus 9. And this plus is the last line in the let. Let, in the same way that proc n, is going to return the result of the last line. And let is going to return that value. The plus was never printed. The plus was returning to let. Let print the result, 18. And if I ask for this x that I mentioned is the same that print x, notice that this one is outside of the let. I already closed the let here. If I ask for a variable x, the local do not exist. We close the let, we close the curly bracket. So all these 3, 9, gone. If I ask for printing x after I close the let, what I already have is my original local variable, that one, and therefore I am going to have a 4. Global variables outside of any function, any instruction, or any block, proc n or let. Local variables inside of a block, in particular, inside of a block that we create with the instruction let. That's it. Global, local, conditions, and loops. Okay, so what if I want to do a program in LISP like for int x that program, what could be the equivalent of that program in LISP? What instructions do we need? Do times? if. What are we going to do with these two here? A local variable with an instruction print. It's going to be a proc n or a let. Oh, there is a variable here, probably a let. Do we need a proc n? Or in this case, maybe we do not need proc n, use the let. Here there is only one instruction. Yes, the do times automatically create this variable, just like the for local. This is a very good example. If you consider this variable x do not exist when the for finish is a local variable to the loop. So that is the same idea with the do time. The variable is going to be local to the loop, only exists for the loop. For your exam, this is going to be a classical question, a piece of software, and just because now you know the syntax of other languages, well, translate. Translate key ideas quickly. Something like that in Lisp, well, something is going to start with open parentheses. And the instruction, we have a for is going to be do times. And the next instruction is going to be again parentheses. And something that you need to remember is, well, what is the first parameter of do times? For the first time, we use something here that is not an instruction. For the first time, whatever is here is not going to be executed. It's just a collection of data, right? The variable. Then the number of times, 10. I can ignore the return, but if you want to return something, it should be there. Yeah. Remember, the idea here is this number is how many times the loop is going to run. So you can imagine equal to 0, lower than 10, it's going to be 10 times, 0 to 9. Or if you want to imagine 1 to lower or equal to 10, it's going to be 10 times. So the number is how many times the loop is going to run, not exactly the lower than something. Or if you think about lower than something, start with 0. Anyway, do times, and then we can start with the instructions, right? Everything after this small configuration thing is the instructions. And, well, the instructions. Open parentheses. And I start with the if. Notice that you can use tabs, like before, enters. You can use whatever you need in order to structure your program, as always, for the computer. All those things, the computer don't care. For the computer, you can write a big line, and it's fine. It's a bad idea. You can get lost. So tabs, enters, it's a good idea to structure things. If the condition, parentheses. After the condition, the if body and the else body. The if body is pretty simple. Parentheses, the instruction, the parameters. And then the else part. For the else, what I have is these curly brackets because I need a body. For the curly brackets, I have two options, proc n or let. In particular, this one is asking me for a let because there is a variable, let, allow me to create variables. So for the let, I do not need the bracket or the else. It's just this space and the next instruction correspond to the else. For the let, important to remember, parentheses. Inside of these parentheses are going to be all the variables. Here, I want a variable y. I want an initial value for that variable y. That initial value is going to be a multiplication. This is my variable y. I can create more variables here. I do not want more. I only have the need for that one. I close the parentheses that correspond. I mean, well. Y, the value of y, the declaration of y, and the closing of the space for all the variables. So parentheses, 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 and at some point I'm closing 3 parentheses. And after that, I can put the instructions that are inside of the let. It's a print. And finally, I can close the let. And when I close the let, I am closing this body there. The last thing that I need to do is to close the loop. And I can put this parenthesis here, so match with the opening. And somehow, in red, one program with 4 ifs in a different syntactical way with other languages, and my equivalence with Lisp. Any question? The X is literally a variable and therefore have values. And each time that the loop runs, that variable is going to have a new value, a different value than in the previous loop. So we can use that value for the index in an array, or the index in a list later, or something similar. As usual, guys, please copy paste the source code in the slides, the thing that we reviewed today. Practice, very, very important. As you notice, we start with something very, very simple, and we need to move forward to something a little bit more interesting. Good. The only thing is here, I am using let because I want to create this variable local. If you use setf here without the let, what you are going to be doing is to create the variable y global. Even though the instruction setf is here, but because y do not exist, that y is going to be created like if you declare y here and you use the equal there. So if you remove the let and you use set here only, this is the result. A global y that is being using here, y equals something. If we use let, then it's not global, and it's like having here the declaration and the assignation. That is the big difference. If a global exists, the only thing that the setf is going to do is the equal. So the variable already exists. The only thing that happens is I change the value. If you use the let, you can have the global y, and you're going to have another y that is local. More or less what happened with other programming languages. Okay, guys, I need to stop here. We continue next lecture. Please review the source code. See you next week. Thank you.